Geometric series is the summation of terms in the geometric sequence. Learn the formulas involved in the operation here in Mathematics of Engineering. Geometric series is also called partial sum of geometric sequence. In the geometric pattern 3, 6, 12, 24, and 48, the geometric series can be computed as 3 plus 6 plus 12 plus 24 and 48. There are two formulas used in finding geometric series. In one case, when the sequence is finite, the formula for the geometric series S sub n is the initial term times the quantity of 1 less r raised to n, all upon 1 minus r. For infinite sequences, the geometric series is computed simply as a all over 1 minus r. Again, infinite sequences continue, and that is shown by having the ellipsis or three dots after the last term shown. The first application is with the sequence -2, 6, -18, 54, and -162. Considering the basic definition of a series, S sub n is computed as adding the terms, which results to -122. Another way to compute for the geometric series is through the formula. With the missing ellipsis, the pattern is taken as a finite sequence. Thus, S sub n is taken as the longer formula. The initial term a is -2, and there are 5 terms in the sequence. However, r is still to be determined. So from the terms, we can take the common ratio as 6 all over -2, which is -3. This is then added to the formula to have -2 multiplied by the quantity of 1 minus -3 to the 5th power, and everything's divided by 1 minus -3. We can simplify this as -2 times 1 minus -243 all upon 4, and that is computed as -122 just the same. Example 2 has a sigma notation where one can notice the rule as a geometric sequence. That is noted by the variable k placed as a power and not just a multiplier. The geometric series at this point can still be computed by identifying each term from k equal to 1 until 7, and doing so, we have 1 if k is equal to 1, 4 if k is equal to 4, 16 when k turned as 3, 64 for k equal to 4, 256 for k equal to 5, 1024 if k is equal to 6, and 4096 when k becomes 7. Adding all these terms, S sub n turns out to be 5461. A shorter method is to use the formula of geometric series with finite terms, and this is started by determining the common ratio, so finding the values of the first two terms is still viable. That is 4 divided by 1 is 4, and that is r. Substitute a, r, and n into the formula and simplify to have 5461. Another evaluation of sigma notation is presented in the next example. The rule has the variable n as a power, so this is a geometric sequence. Also, n starts at 1 and ends at infinity, entailing that this is an infinite sequence. This case can be solved only by formula, which is a all over 1 minus r. Again, We solve for r by identifying the first two terms, where at n equal to 1, a sub 1 is 2 times 1/3 of 1 minus 1, turning out as 2. And at n equal to 2, a sub 2 is twice of 1/3 raised to 2 minus 1, and that is 2/3. Then the common ratio is the quotient of a sub 2 with a sub 1, and that is 2/3 divided by 2, which is 1/3. Place the values in the formula to have 2 all over 1 less 1/3, and we get S sub n equal to 3. Example 4 is a word problem which states a golf ball bounces back off of a cement sidewalk 3/4 of the height it fell from. If the ball is initially dropped from 8 meters, approximate the total distance the ball travels. From this statement, A is 8 and R is 3/4, or that is 3/4. The number of bounces is undefined, thus the series is taken from the formula of infinite sequence. Placing all values for the variables, S sub n is 8 all over 1 minus 3/4, and that is 32.